Introduction to Transformations. In this video, we will cover translations, reflections, rotations, and dilations. The first transformation is a translation. That means the figure stays congruent and slides. The second transformation is a rotation. That means the figure stays congruent, but it turns or spins about or around a point. The third transformation is a dilation. The figure can get bigger or smaller, which means it is a similar figure to the original. And the last transformation is a reflection. That means that there is a mirror image of the original figure, so it stays congruent but changes its orientation or direction. The line that it reflects over is called the axis of symmetry. When we look at a transformation that has taken place, the original figure is called a pre-image, and it is marked with letters like A, B, and C. The new figure is called the image, and it is marked with A prime, B prime, C prime. These little tick marks tell you that this is the new figure. If we were to make a third figure, we would have A double prime, where it would have two little tick marks. We will look at two kinds of problems. The first is how to actually perform each of the four transformations, and the second is when we're given a picture like this, how to figure out which type of transformation occurred and how to describe it properly. Translation. Translate the figure 2 units to the left and 3 units down. This means we need to take each of our vertices, A, B, and C, and count over 2 units to the left, 1, 2, and 3 units down, 1, 2, 3. We mark that point and we label it A prime. Now we'll do that for B. We count 2 units to the left and 3 units down and mark the point. I did the same for C, and I connected my side lengths into a triangle. Notice that the figure is the same orientation or the same direction as the original, and it is congruent or the same size as the original because a translation is a slide. The next transformation is reflection. A reflection is a mirror image of our original figure. It stays congruent, but it will be on the opposite side of the axis of symmetry. The first example says reflect the figure across the y-axis. We call this line the axis of symmetry. I'm going to draw it in with a dotted line. Our image is going to have all of its vertices be the same distance away from this line, but on the opposite side of it. For example, right now, C is 3 units away from this line, but to the right. So C prime is going to be 3 units away, but to the left. A is 5 units away from the axis of symmetry, so it will be 5 units away on the other side. And same with B. The new figure that you've created is going to be congruent, or the same side, as the original figure. It's going to have a mirror image, so C was originally on the left, it will now be on the right. B was originally on the right, it will now be on the left. The orientation is not the same as the original one. The second example says reflect the figure across y equals 4. Y equals 4 is a horizontal line right here. We're going to follow the same process. A was originally 1 unit above that line, which means that A prime is going to be 1 unit below the line. B was originally 3 units below that line, so B prime is going to be 3 units above the line. And C was originally 4 units below the line, so it's going to be 4 units above the line for C prime. This figure here overlapped with the original figure, which you'll see sometimes if the axis of symmetry goes through your figure. Notice that we've created a congruent figure with a new orientation. The next transformation is dilation. This example says dilate the figure using a scale factor of 2. To complete a dilation, we write out the coordinates, then we multiply every coordinate by the scale factor and plot those points. You can even do this without a coordinate plane and just get your new points. I have written out each of the original ordered pairs for A, B, and C. Now I'm going to multiply each coordinate by 2. So A prime becomes 10, 10, because I multiplied each 5 by 2. B prime is going to be 12, 2, because I multiply 6 by 2 and 1 by 2. And C prime is going to be 6, 0, for the same reason. If I had been multiplying by a scale factor less than 1, I might have ended up with some fractions. Now I'm going to plot these vertices. Here's my dilated figure. Each side length is twice as big as the one before, because that's what a scale factor is. Also, I've created a similar figure, but not congruent. Unless the scale factor is 1, you will have a similar figure. Notice that C and C prime, C is at 3, C prime is at 6. And these are all being dilated in relation to the origin itself. The final transformation is rotation. This is a turn or a spin. When you're given a problem asking you to rotate, it's going to tell you how many degrees, the direction of rotation, either clockwise, like a clock, or counterclockwise in the opposite direction, and where you are rotating around, and we use the word about. So in this problem, it says rotate the figure 90 degrees clockwise about the origin. So that's around the point 0, 0. Now, if I imagine that this triangle is rotating clockwise, I know that it's going to be moving this way. So let's look at how we will actually rotate this. For some of us, we may be able to visually do this rotation. For example, if you see that C is 3 units to the right here, and you know that you are rotating at 90 degrees, you may be able to visualize that that point will now end up here. Similarly with B, since it was 6 units to the right and 1 up, in our new direction we'll be going 6 units down and 1 to the right. But for many of us, we're going to use a different strategy. We are going to take our paper and rotate it 90 degrees clockwise, just as the problem says. Then we're going to write down the coordinates as they now appear to us. So this is now the point 0, negative 3. This is now the point 1, negative 6. And this is now the point 5, negative 5. Once you've written those over to the side, you want to rotate your paper back upright, and then you can plot the points. The new triangle that you've created should be marked with A prime, B prime, and C prime. It should have rotated 90 degrees clockwise, which means it rotated 1 quadrant, and it should be congruent to the original figure. If those are not true, you probably made a mistake somewhere. So to recap, first thing I did was I read the problem that said rotate the figure 90 degrees clockwise about the origin, and I rotated my paper itself 90 degrees clockwise. I then wrote down the points as they appear when I've rotated the paper, put the paper back to upright, and I plotted the points. This created my image. The final problem is a rotation around a vertex. This problem says rotate the figure 180 degrees counterclockwise about vertex C. Now, just like before, for a rotation, we need to know how many degrees we're rotating, the direction we're rotating, and the point that we're rotating around. Because it's 180 degrees, the direction doesn't matter. Since we're rotating around vertex C, we will still have C and C prime both at this point, and you can imagine that our triangle is pivoting around that point like a pinwheel. So one way, again, to do this would be to do it visually. So instead of B being up 1 and to the right 3 from vertex C, it would be down 1 and to the left 3 units from vertex C. However, if you're not visual, we're going to do this problem just like we did the other problem. The first thing we need to do is create our X and Y axis around the point that we're rotating around. So in this case, around vertex C. For this problem, we've now made that vertex our origin. The next thing we're going to do is we're going to rotate our paper 180 degrees. Since 180 degrees is the same whether you go clockwise or counterclockwise, it doesn't matter, but I still rotated counterclockwise because that's the direction it says. Now I'm going to write my points, but remember, I'm treating this point right here as the origin. So C is at 0, 0, A is at negative 2, negative 5, and B is at negative 3, negative 1. So again, I used this as my origin, and now I'm going to rotate my paper back upright and plot those points in relation to my new origin. I've now created a figure that has been rotated so the orientation has changed, but it's congruent. It's the same size as the original. I pivoted or rotated around my vertex C, and I've labeled my new points with A prime, B prime, and C prime. So far in this video, we've looked at translations, reflections, dilations, and rotations where you are asked to do the transforming. You'll also see problems where you are given a transformed image and given the pre-image, and you need to describe what happened. When you're describing, make sure that you give all of the proper information. So for example, if you're doing translated, we would say the figure was translated blank units to the blank and blank units to the blank. For example, in the one above, I know that my original A was here, and I moved down 6 units and to the right 2 units. So to describe this transformation, I would say the figure was translated 6 units down and 2 units to the right. I got rid of the to the right here just for grammar. I know that this is a translation because I slid my image, but the orientation is still the same, meaning A is still at the top, B is still at the right, and C is still at the left, and my figure is congruent to the original. If the figure was reflected, I would say the figure was reflected across the line blank. In that case, because it's a mirror image, we would have a congruent figure, but our orientation wouldn't stay the same. For example, if this was reflected over a vertical line, B would then be on the right side, and C would then be on the left side. If it's a dilation, we know that the size changed. So we would say the figure was dilated with a scale factor of, and we'd give the scale factor. We'd take one ordered pair, and we'd figure out what we multiplied the x and y coordinate by, which must be the same number, in order to get to the image from the pre-image. Be sure to look at your tick marks to know which was your pre-image and which was your image. Finally, if we're rotating, we would say the figure was rotated blank degrees, either clockwise or counterclockwise, about or around some point. Most of the problems we do are rotated around the origin. Translation, dilation, rotation, reflection.